Okay, welcome back everyone. In this video we're going to be talking briefly about Newton's third law, or what we sometimes call the law of action and reaction. So what this really comes down to is the idea that in order for there to actually be force, there has to be an interaction between two objects. So that's really what a force is. An interaction between two objects. So let's call those two objects A and B. So what action-reaction says is that if A acts on B, then B reacts on A. So this is kind of an old school way to talk about action-reaction. And action used to be kind of the word for force back in the day. If by back in the day we're talking about Isaac Newton and earlier than that. So that the way that we actually talk about this in practice is for every action there is an equal and opposite reaction. And I think that people are pretty comfortable with this definition, but putting it into practice and really understanding what it means, well, that's another thing. So here's an example of an action-reaction force. Here's a wall, and here's my hand. And somehow I got 4 fingers and a thumb, so that's good. Okay, so an example of an action-reaction force would be the force of my hand acting on the wall and the force of the wall acting on my hand. So hopefully you can see a pattern here, that if A acts on B, then B reacts on A. And those forces are equal to each other but opposite in direction. And we can see that from the diagram. I'm pushing the wall to the left. Let's say that's 100 newtons. The wall is going to push my hand to the right with 100 newtons. So if A acts on B, B reacts on A. Here's an example of something that is not an action-reaction force. Okay? Here's my same hand. Whatever. Okay, that's horrible. Here's my hand, side view. And I've got some sort of an apple or a pear or something, some sort of fruit sitting in my hand. Well, what forces are acting on this object? We have the force of gravity and we have the normal force. This is the thing that really gets people. These forces appear to be equal and opposite, right? The normal force and the force of gravity are equal and opposite. Okay, if the force of gravity is 49 newtons from a really fat 5 kilogram apple, then the normal force has to be 49 newtons upwards. We've already talked about that. But are they a Newton's third law pair? The answer is no. So they are not a third law action-reaction pair. So the question is, why? Well, let's break this down. The normal force is really the force of my hand acting on the apple. The force of gravity is really the force of the earth acting on the apple. So this could be the force of A acting on B, but this would have to be the force of C acting on B. In other words, these two forces act on the same object. And that's the key, is that in order to have a third law pair, the forces have to act on different objects. So it's kind of crazy, but the third law pair to the force of the hand on the apple would be the force of the apple on the hand. and I would have to draw a separate free body diagram for my hand. In other words, action-reaction forces act on two separate objects. Likewise, with the force of the earth on the apple, what would be the reaction to that? Well, I would have to switch that around. It would be the force of the apple on the earth. So, as crazy as it seems, here's the entire earth, and here's this tiny little apple. Okay, if the action is the force of the earth on the apple, then the reaction is the force of the apple pulling up on the earth. And you can see that these are supposed to be equal in magnitude and opposite in direction. So this is really what we talk about when we mention third law pairs. The thing to remember is that if A acts on B, then the reaction is B acting on A. So those appear on two separate free body diagrams.